let's go ahead and jump into our discussion on the architecture and topologies. So when we talk about VMware Cloud Foundation, one of the first concepts that we need to make sure we understand is the concept of a workload domain. So the workload domain is essentially the building block of the private cloud. When you think of a workload domain, think of a pool of capacity that has been carved out for hosting a specific type of workload. And these pools of capacity, these workload domains, they're secure, they're independent, and they're scaled independently as well. So each workload domain is going to have its own vCenter server. It's going to have its own pool of storage. That storage can be vSAN, it can be NFS, it can be Fiber Channel. It's going to leverage software-defined networking capabilities from vSphere with the vSphere distributed switch, as well as have at its disposal the capabilities of VMware NSX and the full set of software-defined networking capabilities. And we basically bring these together in a standardized and repeatable format that makes it very easy to stand it up using a fully automated approach. And once we stand it up, we can then monitor it with VCF operations. And if we need to scale it up, scale it out, we can again leverage automation to do that. So the workload domain is key, and it's very important you have a good understanding of the concept of a workload domain. And to help underscore that, let's look at an example here where we have a VMware Cloud Foundation environment deployed in a data center. Now you'll notice that I'm starting with a management domain. The first there's two types of domains in Cloud Foundation. We call the first one the management domain, and the other is a virtual infrastructure workload domain. Those are the two types. The difference between the two and the significance of the management domain is the management domain is where it's a special purpose domain because one, it's the first domain that gets created as part of a VCF instance. And it's also the domain where we're going to by default host all the vCenter servers, the NSX managers, as well as the fleet components such as VCF operations and VCF automation. And we can also have other components like NSX edge clusters running in there. But the point being that the management domain is where we host the infrastructure components or the infrastructure management components that are used to manage the private cloud. And so we put those in that first cluster, the first cluster in the management domain. And so that's the significance of the management domain. Now, when we want to go in and we want to start deploying workloads in our private cloud, we look at the data center as a pool of capacity represented here on the slide as the inventory. And now if I want to go in and deploy some workloads, say I have some traditional VM-based workloads, I want to go in and create a workload domain for that. So I'll go in and I'll create a production cluster. And then maybe I have some developers who are wanting to do some Kubernetes work, and I maybe have some people wanting to look at using private AI. And they want to run this all on the infrastructure that I own and manage inside the data center. So I go out and I create these workload domains. So here I've created three VI or virtual infrastructure workload domains, one for production, one for private AI, one for Kubernetes. And again, each of these is isolated behind its own vCenter server. Each has its own pool of storage, it's separate networking, and it's an independent pool of capacity that's available for hosting workloads. Now, in addition, I can scale these separately as well. So for example, here I have my private AI, but it's only got two servers in it. And maybe after I do initial set of tests, I realize, hey, I need more capacity in my private AI workload domain in that first cluster. So what I can do is I can go back to my data center where I can provision some more resources in the data center and put those in the inventory. And then I can go in and use the automation to basically expand that private AI workload domain by adding hosts to that existing cluster. So this is just a quick example to kind of underscore this concept of a workload domain and how we can basically provision workload domains. Now, I'll just take a moment to kind of underscore that here, everything's a single cluster. But in reality, a workload domain can have one or more clusters up to vSphere maximums. So you can scale up quite large with a VMware private cloud based on VMware Cloud Foundation by leveraging this concept of workload domains and scaling to a large number of clusters behind them. Now, in addition, I've touched on this before, but when we look at these workload domains, we have to understand too that workload domains they don't always run in the data center. Sometimes they need to be stretched across data centers, or what we refer to as availability zones in a stretch topology. And we do have support for vSAN stretch clusters. And sometimes we may need to run these out at the edge as well. And we can also deploy Cloud Foundation in the public cloud in order to have Cloud Foundation running in the public cloud as well. But the point being here that with workload domains, we have this ability to go in and using automation to stand up this standardized, repeatable pool of infrastructure that can then be managed and scaled individually. And we can do this in a way that's stretched across data centers for high availability, data protection as a vSAN stretch cluster, as well as out to remote sites for supporting edge use cases or retail use cases or things like that. Okay, so that's the concept of a workload domain. Now, the second concept we need to be aware of is this idea of a VCF instance. So everything I've talked about so far with having a VCF management domain with one or more virtual infrastructure workload domains, that represents a VCF instance. Each VCF instance is going to be designated by having a single management domain. And as we've seen, you can go into a VCF instance and you can add additional VI workload domains in order to help scale that up. And of course, in this management domain and this VI workload domain, you can have many clusters as well. Okay, so that's a VCF instance. Now with VCF 9, we're introducing a new term called a VCF fleet. And essentially, what a VCF fleet is it's a collection of one or more VCF instances. And what makes a fleet unique is that the fleet is where we run the fleet level components that span across VCF instances. This includes VCF operations and VCF automation. So while I can have a single VCF operations instance and a single VCF automation instance managing multiple VCF instances. So, and then that way I can scale out. And as I deploy in multiple locations, I can deploy a fleet in my first data center. I can deploy a fleet in my second data center, a fleet in my third data center. And then I can basically have these fleets acting as my VCF private cloud. So again, the workload domain, the VCF instance, and the fleet. So I kind of did that from a bottom up, but if you look at it from a top down approach, we start by deploying a VCF fleet. That VCF fleet is comprised of one or more VCF instances, and those VCF instances are comprised of one or more workload domains. So that's the terminology. So hopefully we're clear on those components and how they are kind of relating and how we can build a private cloud using those. Now we'll get into a little bit more detail around how we deploy the clusters and inside these workload domains. So there's a couple of options here. So one of the options that we have is when we stand up a new VCF instance, I can basically have a separate management domain where I host those infrastructure components that I mentioned earlier, the vCenter server, the NSX manager, my operations, my automation. I could put those in that management domain, and I can leave that management domain dedicated for those infrastructure components, thus ensuring that I have separation of my management from my compute workloads, making sure that I have resources dedicated to each. And then I can go in and create virtual infrastructure workload domains to host those user workloads or those compute workloads in my environment. And so this is the default architecture. Traditionally, we've called this the standard architecture. But we do have flexibility, and one of the themes you'll hear as we go through this presentation on VCF 9 is this idea of flexibility and meeting customers where they are and giving them flexibility in how they deploy Cloud Foundation. Because in addition to having this standard topology that I've just discussed, we can also go in and do what we call a consolidated deployment, where maybe I have a smaller deployment, or maybe I want to start small and then scale out. So maybe I don't want to start with two domains. I just want to start with one domain, but I want to have enough hosts in that domain to maybe I could put some my infrastructure on some host, my compute workloads on other hosts. I can basically run them together on the same domain. And that's definitely doable. And that's what we call this consolidated architecture. And this is where you basically deploy a VCF instance with a single management domain, and then you use resource pools to provide isolation between the infrastructure components and the compute components. And this works great, particularly in some of the smaller use cases, maybe some of the remote edge use cases. But again, both are viable options, and it's there for our customers to kind of look and decide which option would best meet their needs. Now, in addition to being able to deploy um, the standard architecture, the consolidated architecture, we also have different ways of providing availability for the clusters that make up our workload domains. So, for example, by default, we will deploy all the clusters in a single rack. So this has some benefits. You put everything in a single rack, and particularly if you're using something like vSAN, where you have the hyper-converged infrastructure and you're using the storage in there, all the east-west storage traffic is going to be confined within the rack. So you're not sending a lot of your storage data up to the top of rack switches and out across the top of rack switches out across the spine. You're keeping that all contained within the rack. So there's some benefits to that. However, the disadvantage to that, of course, is what happens if I lose a rack? Well, if I lose a rack, I would lose my entire cluster. So we do have the ability to support cross rack deployments as well, where I can take a workload domain, I can take a cluster in a workload domain, and I can span that across racks. Thus, if I lose a single rack, I can make sure that I have resiliency in my fault domains as configured in vSAN in order to ensure that I can survive a rack failure. And of course, as the diagram is showing here, I can mix the two. I can have some clusters in one rack, other clusters spanning across racks. But again, the point here is I have flexibility. The customer has flexibility in order to choose which deployment model will work best for them. Now, in addition to being concerned about rack resiliency, some customers may have multiple data centers in a close proximity to each other, and they may want to take a step further and introduce stretch clustering with vSAN stretch clusters, where they basically stretch a cluster across availability zones. So here you'll see we've taken that workload domain 2, we've added another cluster that is stretched across a rack in availability zone 1 and a rack in availability zone 2, thus providing a higher level of data protection by allowing us to survive a larger scale outage within a single data center or a single data center hall, and by stretching that across to another availability zone. In addition to the resilience that was built in, we also have support for vSAN storage clusters. So this is where I can build a storage cluster and I can have that comprised inside of one rack, and then I can mount the storage provided by that storage cluster off into other clusters running in other racks. So as you can see, when it comes to the workload domain and cluster topologies, we have a lot of options, we have a lot of flexibility. And so so we can definitely go in and satisfy pretty much most customer use cases in the sense of, do they want to separate compute from management? Do they want to run together? Are they worried about rack resiliency? Do they want to spread across racks? Do they want to stay within a rack? Do they want stretch clusters? And are they looking at something like vSAN storage clusters? Regardless of what they're looking for, we have the support for a topology that will meet those needs. And it's taking this a step further. We looked at within the data center, but now let's talk about remote clusters or remote sites. So we go out and we're outside the data center now, and maybe we have some remote sites, and maybe we have just a small number of remote sites, and we want to put a separate workload domain out at each of these sites. And we want this workload domain to be kind of self-sufficient, independent. But we want to be able to centrally manage it from the SDDC manager and from VCF operations. So we can definitely do that, where we can just go in and put a cluster at each remote location and centrally manage that. In addition, we can go in and we can take that a step further, and we can go out and we can have remote sites where we have multiple clusters. We can pick and choose the topology we want, whether the vCenter server runs in the main data center, the central site, or whether the vCenter server is going to run at the remote site. Of course, there's implications with each of these decisions. Being primarily around the type of networking that you're using, the location of the vCenter server, and the ability to scale and scale up and scale out. And so there are some pros and cons with each approach, but the point being that as your customers looking at their remote site needs, they look at their need for, how do I going to manage this? How am I going to scale this? They can basically choose an architecture that works well for them, and keep in mind there are implications on those decisions, as it may influence the type of networking they use, or it may influence how much bandwidth or latency requirements are needed, and the availability of those as well. So the point here being, again, flexibility and the ability to basically support deploying VCF at the edge in these remote topologies, using a number of different supported topologies with Cloud Foundation.